Dryness in many European countries and the parallel expansion of the bark beetle population makes European forests suffer. Large forest grounds have to be replanted. So, what should we do with the dead wood and the bark beetle polluted wood? One answer could be systematic use as recovery derived fuel, RDF. Normally, we would use this term for plastics and fiber waste, not for wood waste. But the environmental value of wood waste as RDF would come from its status. A waste without value becomes a valuable fuel. Burgundy case study: shavings and sawdust become pellets. MG Granules is a producer of high-quality wood pellets in Argenteuil-sur-Armançon in France. It is a family-run business with a small initial plant organization. During the engineering process for the new plant, the main question was how to install one pelletizing line and how to add a second one after 2 years. How to double the process without doubling the footprint? One of the answers came from the Gerdes dryer tower principle. A first tower could be installed in the first phase of the project, and a second one could be installed at a later date. Even power adaptations are possible in the way that the modular approach allows the addition of drying stages without changing the footprint. Such a drying stage can accept 200 to 300 kilowatt of heat power. The machine must be completely housed to avoid dust spreading all over the plant. The material is spread out and dosed to create a constant product layer across the entire width of the dryer. When the dried product leaves the dryer, it will look like the product layer seen in this figure. The plant manager mixes up different pellet arrivals before putting them into the dryer and does it in a second time before they enter the shredder. In this way, the pellets should have constant moisture degree, constant fiber characteristic, and constant behavior during combustion. The 4-stage dryer would dry shavings and sawdust through the Volling process with the help of 1 megawatt of heat power at 80 degrees Celsius. Ambient air temperature is 10 degrees with 80% saturation degree. Humid chips enter at the rate of 1.4 tons per hour at 50% relative moisture degree, and they will leave the dryer at a rate of 0.8 tons per hour at 12% relative moisture degree. The dryer will remove 600 liters of water per hour. Belgium case study: barks, leaves, roots and wood chips become standard boiler fuel. When its wood took over the plant from Comboubois in Fauvillers, Belgium, the new owner wanted to replace the ancient rotary dryer, high temperature, with a more adapted drying system. The idea was to produce standard wood chips fuel by drying with heat coming from the adapted boiler. A low temperature dryer helps to avoid fire or explosion risks that might occur more often at higher temperatures. The dry product enters the hall to be separated from iron materials via a magnet and to be screened into the Mulk fraction and the classical wood chip fraction G100. The inlet of the humid product is done by a simple belt conveyor, as seen in the figure. The installation does not need housing, as neither sawdust nor shavings are present. The valorization process of forest byproducts at its wood is shown in the following figure. The three-stage dryer would dry wood waste through the following process with the help of 750 kilowatt of heat power at 80 degrees Celsius. Ambient air temperature is 10 degrees with 80% saturation degree. Humid chips enter at a rate of 2 tons per hour at 40% relative moisture degree. They will leave the dryer at a rate of 1.6 tons per hour at 25 relative moisture degree. The dryer will remove 400 liters of water per hour.